Here we go. So we have two objects, A and B. Okay. There is, let's say, 1,000 meters between them. The mass of A is 500 kilograms. The mass of B is 50 kilograms. And so they were 1,000 meters apart. What is the they're 1,000 meters apart. Okay, cool. What is the acceleration of both? And how far apart are they after, let's say, 100 seconds? Okay, how far apart are they after 100 seconds? Okay. So unless we get some questions, this will be the end. It'll be nice quick for a short unit. Okay. So, first things first, we have two masses and we have a radius. More or less, the only thing we can directly calculate that's relevant to this unit is our gravitational force. Okay. So, since the force is equal to both, since the force is equal for both, we can calculate it right here. As hard as one pulls on the other pulls on the other. Equal and opposite reactions. So we have 6.674 times 10 to the negative 11 multiplied by 500 kilograms multiplied by 50 kilograms divided by 1,000 squared equals our force. And that's not going to be very much, which is, pretty realistic for stuff this small that's that far apart. 6.674 times 10 to the negative 11 times 500 times 50 divided by 1,000 times 1,000. So that tells us that our force on each one is 1.6685 times 10 to the negative 12. I should have put these closer together. Times 10 to the negative 12 newtons. Now, that's very, very small, but it's not nothing. Okay? And let's change this one a little bit. So, A of A and A of B, because those will be different. And then R of, let's say, 1,000 seconds. Change that just a little bit. So that's how much force is acting on either. It's pulling on both directions. So it's acting for both. Now, for, let's say, mass A, we have an acceleration of A, and that's going to be 500 kg multiplied by whatever the acceleration is equals this number right here. So if we divide both sides by this 50, our A sub A, or 500, is equal to 3.337 times 10 to the negative 15 meters per second squared. A sub B would be this number right here divided by 50. Divided by 50. Or 3.337 times 10 to the negative 14 meters per second squared. Okay? So let's go ahead and write these in over here so we can erase all this stuff over here. 3.337 times 10 to the negative 15, 3.337 times 10 to the negative 14. Okay. Let's get rid of this stuff. Okay. Now, what we're interested in is a delta x for A and a delta x for B, because we know, let's say they start from rest, and we know their acceleration, we know our time. Our time is 1,000 seconds. What we're going to do is we have 1,000 meters between them. B is going to move this way, and A is going to move this way, and we need to see how far apart or how much they move after 1,000 seconds. Now, here's our all-purpose displacement equation. But as I said, they start from rest, so we can knock that part out. And when we write it down here, we just have this instead. So we have 1/2 times 3.337 times 10 to the negative 15 multiplied by 1,000 seconds, or 1,000 seconds squared. And that equals times 0.5 times 1,000 squared, or 1,000,000. So 1.6685 times 10 to the negative 9. Meters. That's how much it's moved towards the center. Now over here, same deal, but a different acceleration. So 1/2 3.337 times 10 to the negative 14 times 1,000 seconds squared equals same deal, but one less for the value of the exponent. Okay, so how much closer are they together? They're essentially 0. But let's go ahead and figure out what it would take, how long it'll take for the two of them to run into each other. Now, let's keep in mind our displacement equations. Okay, so delta x, delta xa, and delta xb are both equal to their accelerations multiplied by however long we have. And it's going to be the same time for both, right? Now, in order for them to touch, the amount that delta xa moves plus the amount that delta xb moves has to be 1,000 meters, right? So we can say that, let's say, delta xa equals 1,000 minus delta xb. Let's just define it that way. Now, since we know how to define both of these things, we have 1/2 acceleration of A multiplied by time squared equals 1,000 minus 1/2 AB multiplied by time squared. Okay? So, and these times will be the same because that's how long it's going to take. Now, if we move this side back over, I shouldn't have moved these, but if we move them back over, we have 1/2 A sub A plus A sub B multiplied by time squared equals 1,000. Okay? And we know numbers for all these except for time. Okay? So 1/2 3.337 times 10 to the negative 15 plus 3.337 times 10 to the negative 14 multiplied by time squared equals 1,000. Now if we divide both sides by this much, I typed it wrong. 3.337 negative 15 plus 3.337 times negative 14 times 0.5, 1,000 divided by that. And we end up with a delta t squared of 5.449 times 10 to the negative, or times 10 to the 16. And if we square root both sides, let's go ahead and see what it, 2.33 times 10 to the 8. So our delta t is 2.33 times 10 to the 8 seconds. Now I don't particularly know what that is in seconds, but let's go ahead and figure it out. Everybody take a look at this before I erase some stuff. So we're going to hold on to our time right down here. So that was nearly 1,000. But so our time, 2.33 times 10 to the 8 seconds. Let's figure out how long that is in, let's say, years. So how long would it take a 50 and a 500 kilogram weight positioned 1,000 meters apart to run into each other? Okay? And we can figure out how fast they would be going. It still would be almost nothing. But anyway, so we have 2.33 times 10 to the 8 seconds. What I want is to figure out how many, let's just figure out how many years that is, okay, because it's multiple years. So for every second, okay, let's say 60 seconds in 1 minute. That cancels out those seconds. But let's also say for every 1 hour, there are 60 minutes, and that cancels out those minutes. And let's say for every hour, or for every day, there are 24 hours. That cancels out those hours. And then for every year, there are 365 days. So that cancels out those days, and we end up with years. So we need to take this number, divide it by 60, divided by 60, divided by 24, and then divided by 365. So we have our number divided by 60, divided by 60, divided by 24, divided by 365. So our delta t in years turns out to be 7.4 years. So if we were to set up a 550 kilogram mass, 1,000 meters from each other, it would take them 7.4 years to collide.